Hey guys, so in this lesson we're going to look at what happens when you add a sine to a cosine. Now in particular we're looking at this question. I want to be able to add these two together and find out what we get. But before we go into that, we'll just have a look at what we actually would get if we add a sine and a cosine together. So here's a picture of that. Here's a sine wave and a cosine wave on Desmos. So the red is the sine, which starts at 0, 0, and cosine is essentially the same curve, but just translated back 90 degrees or pi by 2 radians, depending on how you want to view it. Radians wise, that's what's on the x-axis here, so in radians. So if I add these two together, I'm going to get sine x plus cos x. Okay, so it's going to look like that. So that's a combination of the two, which is adding in all the places where they can combine. So for example, at this point here, we have 0 and 1. So 0 and 1 makes 1, so it adds up to make this third curve 1. Here, the value of the height at this point, which is pi by 4, is 0.707. And since this is where they cross, if you add the two heights together, so 0.707 twice, directly above that, we'll find the value is 1.414. So just double it, just double the height there. And as we go along, the black and the red curves combine to make this thicker red curve. So for example, here, as the cosine curve is going down, it's kind of pulling the red down, so the bigger red curve comes down. Here, they're both below the x-axis, so their combination is below from this point forward, so here. As soon as this one goes below, you can see, because it's 0, the value is the same. And then as they're both below, they combine to do the reverse of what we had before, and they go down to minus 1.414. So what we want to be able to do is do this for any curve. So I'll just show you what those two things have generated. So I'm going to just put in what the actual value is. So I'm going to show you it's root 2, and that is going to be times by sine x plus pi by 2, which is 0.1.87. 1.57 divided by 2, so 785, sorry, 785, there we go. Go on, divide, there we are. So as you can see, the purple one must be the same as sine x and cos x, because it's now been obliterated, we can't see it. So when we did root 2 times sine x, we got a curve which is the same height, 1.414, but then I had to move it left to get it to cover the red. So pi by 2 will do that for us. So what we're going to look at is how to calculate this, how to figure it out, how to calculate this. As you can see, different values of this angle make for different translations. So we want the translation that will land on top. So that will be 0.785. So I'm going to show you how to do that. In particular, I'm going to show you how to do it for the question we just looked at, which was 3 sine x plus 2 cos x. So 3 sine x essentially is just sine x times by 3. So notice the red one has now got a height of 3, so it's 3 times bigger. And 2 cos x is essentially cos x times by 2. So it's twice as high now, because 2 instead of 1. So their combination, when you add them together here, it's going to be 0 plus 2 is 2, so that's why it goes through there. Here, they're combining to form this height here, which is going to be 3.606, so we're going to show how to find that. And we've also got a phase shift, so we're going to see what that looks like. So that's what we're going to work on. So let's go back to our question and have a look at it. So we've got express 3 sine x plus 2 cos x in the form r sine x plus alpha, and we use radians, want the alpha to be between 0 and pi by 2. And we'll come to the second part in a minute. So first of all, let's just look at how to calculate that. 3 sine x plus 2 cos x. Let's put it in the form r sine x plus alpha. Okay, so we have 3 sine x plus 2 cos x, and we want it in that r sine alpha form. The first thing is we need to know what sine alpha plus, sine theta plus alpha is. So from a compound angle formula, that is sine theta cos alpha plus sine alpha cos theta. And if we times that by r, then both of those will be times by r. So r sine alpha plus theta, r sine theta plus alpha is equal to that. R sine theta cos alpha plus r sine alpha cos theta. Now what we do is we compare coefficients. So if we look at our sine x and cos x, we just need to change that slightly because we want that in terms of sine x plus alpha. Actually, I'll have it in theta. So it should have been, let me just quickly alter that. This theta should be an x. So any theta, I'm just replacing with an x now. Okay. So it's r sine x plus alpha. Okay, so times that by r is going to be r sine x cos alpha plus r sine alpha cos x. Now I can compare the coefficients because both of them contain sine x and cos x. So what we do is we say, okay, well, r sine x cos alpha is very similar to 3 sine x if r cos alpha is equal to 3. So I'll write that down. R cos alpha will be 3. Because if r cos alpha was 3, that would be 3 sine x. And the 2 cos x, if r sine alpha is 2, that would be 2 cos x. So I'll write that down. So what I'm going to do is a little trick and write it above. So r sine alpha is 2. Now, I want to know, basically what I'm trying to find is what r is, what is the new height of this combination of waves, and what is the angle, what's the translation, which is what the alpha that we're looking for. So I'll just divide them. So I do r sine alpha divided by r cos alpha is tan alpha. Since the r's cancel and sine divided by cos is tan, and tan alpha is 2/3. So to find alpha, we're just going to use inverse tan of 2/3, which in radians is 0.59 radians. So inverse tan of 2/3, 0.59 radians. Okay, so we've got alpha. Now to find r, we're just going to utilize Pythagoras' theorem. So if r sine alpha is 2 and r cos alpha is 3, what we can do is use a right angle triangle and call the hypotenuse r. There's our angle alpha. If r sine alpha is 2, that basically means that the height is 2, because sine alpha is height. That's if only if the hypotenuse is 1. So it's not, it's r, so it's 2. And r cos alpha is 3. Cos alpha is the width, so r cos alpha is 3 means if the hypotenuse is r, the width would be 3. So from there, we can simply use Pythagoras' theorem. So 2 squared plus 3 squared is r squared. And you can see that that would be 13 is r squared. So r is root 13. Root 13 is a prime number, so that's not going to simplify. So as a decimal, if you wanted it as a decimal, whoops, that's not allowed square root. Just want our answer, which is 3.6, there or thereabouts. Okay, so this means that we can re-express 3 sine x plus 2 cos x, 3 sine x plus 2 cos x, as this combination of two waves makes a single sine wave with a height or amplitude of root 13 and a phase shift of 0.59 radians. There we go. So if we go back to our picture and have a look at the values, we'll see that the height here is 3.6, in other words, root 13. And the phase shift will be this distance from 0 to this point here, because it should start, the sine curve starts here, but it's gone back a little bit. So let's have a look at what the value is, and surprise, surprise, 0.59. That's our phase shift. And it's minus because remember that that's what the x value must be to be 0, minus 0.59, or 5.88 is the actual correct figure, plus 0.59 makes 0. Sine of 0 is 0. So it's the x value that that's demonstrating will give 0. So the phase shift cancels that. This number here, sorry, cancels that phase shift out to make 0. Okay, so that's the whole idea. We're just trying to find out what happens when you add a sine wave and a cosine wave together, no matter what those amplitudes are. Essentially, we're just going to use inverse tan and Pythagoras. Now, there's a button on the calculator that I'll let you check this very quickly. Before you do all your work, you can just actually put the numbers in. It'll tell you straight away. So let me just show you what that is. Oh, there it is. So let's just check you can see that. There we go. Yeah, you can. So here above the plus button is pol. And if you press shift pol and type in 3, 2, close bracket, it will say this. It will say root 13 and 0.59. So it'll quickly tell you those two values, and you can just double check that you've got the correct calculation from that. Now, it's important that you do it in that order. It has to be 3, 2 and not 2, 3. If you do 2, 3, it'll be wrong. So you have to do it in width, height order because it's x, y in the coordinates, x, y. So width is 3, height is 2. How to know that? Well, it comes from our either from our triangle or our initial comparison. So sine is 2, so that's height. Cos width is 3, so that's width. So width first, then height. Okay. With practice, you'll start to quickly do that and notice which one's which. And even if you get it wrong, just try them both ways. You know, if one's wrong, try it the other way, and one of them's going to agree. But just take care it's correct. If you've got a graphical calculator, you're going to have to hunt in the menus to find it. So if you will find it in there if you press Option and go to the right menu. So if you go to Option and then Angle and then Right, eventually you'll come to Pol. Now there's also an online calculator for this. So if you're working online and you want to calculate it, Pol is short for polar. So just type in 3 and 2 and calculate it. And it's not done it for me. Let's try that again. Let's reload it. There we go. So 3 and 2. Calculate the suitable coordinates. So we have root 13. There we are. And our angle is 0.58. Lots of decimal places. So 3.6, 0.58. If you put 2, 3 in, let's do it the reverse way, see what that gives. We're going to see that we're actually going to get the same root 13 because it's the same thing. The angle will be wrong, so it's 0.98. That's because now you've made the height 3 and the width 2. So that's heading towards about 57 degrees, which is about 1 radian, so 0.98. Okay, so let's have a look at another problem like that. Most of the problems are in this kind of form, where you're trying to just simply just figure out what happens when you add a sine wave and a cosine wave together. The answer is you get another sine wave. So let's actually put that in and see if it covers it up. So root 13. Before we move on to the next one, let's just show you that. So root 13 and then times, oops. I'm screwing this up. Root 13, root 13. Here we go. Second sine. Sine. He's creating a division for me. Why are you doing that? There we go. Oh, why doesn't? Oh, I know. I've got a wrong language. Polish again. Reading my life. So let me put that there. Okay, there we are. Eventually got there. I was pressing the wrong buttons. So root 13 sine x plus, notice the black one covers up our 3 sine x plus 2 cos x, which is the blue. When you put the correct phase shift in, the height is correct because root 13, and then 0.5958 for absolute accuracy. And there we go. So that's the whole idea. Trying to combine those two ways and see what do they make, how do they make one single sine wave of what amplitude and what phase shift. Right, so let's have a look at another example of that. So I want to look at this one. So let me put that one away. We'll look at that later. This one, we've got a similar setup, 3 cos theta plus 4 sine theta in the form of cos theta this time. So we want it as a cosine wave. And again, it's in radians. And then there are some further questions on that. So you just want to pause the video there and have a go yourself. So you need to look up your cos, if you don't know it already, your cos compound angle. Pause the video and see if you get the same results. It's also worth using your poll button to see what the values would be. So you're going to be typing in 3, 4, and that's it. It'll tell you R and it'll tell you alpha. So pause there and then replay when you're done. Okay, so hopefully that okay. So we're going to write 3 cos theta plus 4 sine theta. So notice this time it's theta. So it could be theta or x. We want it in the form r cos theta minus alpha. So r cos theta minus alpha will equal r cos theta cos alpha minus r sine theta sine alpha. Again, we're going to compare coefficients. So 3 will be r cos theta. So r cos theta is 3. Because, sorry, wow. R cos alpha is 3. We're trying to find alpha, not theta. So r cos alpha must be 3, because if it is, then we get 3 cos theta. And r sine theta is 4. Now, take care, because I've made a sign error. That should be the opposite sign for cosine. So r sine theta, because they need to match up, you see. That's a plus and a plus. But that's what cos theta minus alpha is. It's a plus sign, the opposite. So r sine theta is 4, r cos alpha, oh, do that again. Oh, r sine alpha is 4, r cos alpha is 3. So again, we'll divide those. So tan alpha is 4/3. And we need to find the inverse tan of 4/3. We're doing it in radians. So just do a quick inverse tan on your calculator, 4/3. So it's about what, 0.9 radians from the top of my head. We'll see. The exact value is 0.927. I know that one well in degrees because it's 53.13 degrees. It's a famous triangle. Okay, so we got the alpha. Draw the triangle. R will be I put on use the height is 4 because it's sine alpha, and the width is 3 because it's cos alpha. So it's just going to be, probably you can see already, it's a 3, 4, 5 triangle. So 3 squared plus 4 squared is 25 equals r squared. So r is 5. I'll just skip the Pythagoras there, but you should do it in full if you're doing it in an exam. So that'll give us 5 cos theta minus 0.927 as our answer. So that means it's going to move right 0.927 degrees because minus. So that means it's the distance from here to here should be 0.927. There we go. That's what it says. Perfect. Because it should be sat here. But here it's actually sat here instead, which is to the right 0.927. It's got a height of 5. That's its amplitude. So that's what we'd expect. So we're all good there. Excellent. So next question. Next part of that question was, let's get rid of that guy. Hence find the range of the function where 7 plus this. F of theta is 7 plus this. So essentially what's happened is the same thing, but it's been moved up 7. Now we know that it's got an amplitude of 5. So that means its lowest point is going to be minus 5, and its highest point is going to be plus 5. So the range will just be 2 to 12. 7 take away 5. 7 plus 5. And again, we can test that. I can just put in a 7. And we see it goes up, moves up, gets transported up 7, and its lowest point is at 2, its highest point is at 12. So that's our range, 2 to 12. You can use your calculator for that as well, but hopefully you'd see it just adding 7 will just move the whole thing up 7. So our range goes from being minus 5 to plus 5, and so that's just going to get affected by 7. Yeah. Okay, and then the next question was write down the greatest possible value of 7 plus blah 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 blah. So the greatest possible value of that would be when the denominator is smallest, small as it can be, because it's 1 divided by it. The bigger the denominator, the smaller it will be. So the very lowest value, since we know the range is from 2 to 12, the lowest value would be 2. So the greatest possible value of that would be 1 over 2. So it would be 1/2. So it'd be 1/2. Okay, so let's have a look at the third scenario. Express sine theta minus 3 cos theta in the form r sine theta minus alpha, etc., etc., and solve the equation. So to solve that equation, we'd ideally like it in just a single sign, and then we can do inverse sine. So we just do exactly the same thing. I'm just going to use sine theta minus alpha. This time it'll be sine theta cos alpha minus cos theta sine alpha. And then we compare coefficients, etc., etc. So again, what's the number for sine theta, which is in front of it? It must be 1. So 1 is the height, 3 is the width. No, excuse me, other way around. 1 is the width, 3 is the height. And you can check it on your calculator and so on. So I'll leave that for you guys to give it a go with. It's quite straightforward procedure to do, because all you got to do is tan and inverse and Pythagoras, but you've got to set it up right. Okay, so it's a good idea to draw it. It's a good idea to check it on the calculator, make sure it all makes sense and corresponds to it. Even draw it on a graph if you've got a graphical calculator. And once you've done a few of these, you see that it's quite a straightforward procedure. Okay, so I'll stop our video there and see you in the next video.